Hi there, Andrei Maximov is here. Welcome back to our quick introduction to Python 3 for AWS Automation Engineers course. This course is completely free and available for you at handzon.cloud website. In this course, we are covering Python basics and of course various different aspects of using boto3 library to automate your daily AWS routine operations. In today's video, I will show you how to use boto3 library to work with Amazon Simple Storage Service or Amazon S3, and we will cover the basic operations for S3 buckets like create, list, delete, of course enabling version support, and some other operations, and we will cover the basic operations within S3 objects as well, like how to create them, list, delete, rename, update, and generate precise URLs, of course. So if you are ready to get started, let's dive into the topic. Okay, I'm at my Cloud9 ID, and as you can see, I already created a boto3 S3 folder to store our code examples, and within this folder we have two separate files. One of them is bucket.py to illustrate the S3 bucket operations, and objects.py, which we will use to illustrate the S3 objects API calls. Now, let's start from list buckets first. So every single time I need to implement something using boto3, I'm going to the boto3 official documentation, then I'm going to the list of available services, and then I'm searching for the service name, which is in our case gonna be S3. Let's click on it, and here of course this is the primary source of the documentation which we need to rely on while we developing our AWS automation for every single service. So to list buckets available in your AWS account, we need to use a service resource. Of course we can do it using client, but I would like to show you how to use boto3 clients and resources at the same time in your Python program. So I open the service resource first, and here's the resource definition, and as soon as we define the service, as soon as we will define the S3 resource, we will need to use its buckets collection to get a list of buckets from the AWS account. So first of all, let's copy this import declaration over here and paste it here. And instead of using S3 as a variable name, we will use S3 resource, just to make these things a little bit cleaner. Now, as I already told, we need to be using buckets collection to get a list of all buckets from our account. As you can see, there are a couple of methods over here. One of them all, another one is filter. Basically, the difference between those two usually is that all returns all available resources from the collection, and filter allows you to filter the items from the collection. But in our specific case, the buckets collection does not have this filter method implemented. I mean, the method itself is implemented, but under the hood it will call all, and this method call will still return all the buckets. Why this is happening? This is happening because this filter method is relying on AWS API, which is list buckets API call, and this list buckets API call does not use any parameters, so it doesn't allow us to filter anything what we are getting from this action, like list buckets. So that's why the filter method over here doesn't accept any parameters. So not to confuse the developers in the future, let's use this buckets all method to get a list of all the buckets from AWS account. So to do that, we are copying this line of code here. Let's rename the bucket iterated to simply buckets, and this buckets variable will contain a list of the list of all buckets from our account. Of course, we see an error here, and Cloud9 IDE shows us that error, and basically it shows us that the variable S3 is not defined. This is happening just because we renamed our S3 variable here, and we need to use it over here. So basically the logic here is the following. We are using the resource to get access to the collection of buckets, and then we are calling the all method from this particular collection. Okay, now to list the buckets, let's define a separate, a specific method to do the separation. And let's call it list buckets. Now, let's move those two lines to this method and start using them. So to list all the buckets or print all the buckets, let's print them. We need to use a for loop where we will be iterating through the entire list and get access to every single bucket, and then we will be using print statement and f-string interpolation syntax to print all the buckets names. So to get access to the bucket name, we need to understand which attribute to use from this variable. Let's go back to the documentation, and as we can see, this iterator will return us a list of S3 buckets. So now we need to go back to the service and see a list of available sub-resources. And here we will find the bucket class, and that's the exact class which gonna be returned from this method. So this class has a return type which is S3 bucket, and let's click on it to see the reference of all available identifiers, attributes, of course supported actions, sub-resources, and many other interesting things over here. So to get a name of the bucket, we need to get access to the name attribute over here. So that means that here, let's create a separate variable like bucket name, and specify it is bucket dot name. And here in this print statement, we will use the bucket name variable. Okay, fine. Now we need to call this method in our Python program. So let's use the default if method declaration for the Python program. If name equals main, and then call this list buckets method. So now, if we will execute our script, we should get a list of S3 buckets available in our account. So let's type Python in the CLI, Python, then boto3 S3, and then bucket py, the actual file name of the file where we define this Python code. Now, what we can do here, we can execute it. And as you can see, I already activated my virtual environment where I installed boto3 at one of our previous videos. So as you can see from the output of our script, we are printing all the bucket names. Now let's take a look what S3 bucket names do we have in our account in AWS console. And here's the actual, pretty much the same list of S3 buckets. Now, here in this table of all the buckets, we have an additional information like AWS region or bucket location. And this information is not available in the resources of boto3, and it can be requested only from the S3 by using S3 client. So to do that, we need to define a boto3 client first, right? So let's copy this client definition from the boto3 client and paste it over here. So instead of the client we'll call it S3 client. Let's put this additional line as a separator. So now we define the client, and within the client, let's search for get bucket location, and here we will see how do we need to call this get bucket location method, what kind of arguments does it support. In our case, it supports just only 2 arguments, like bucket and expected bucket owner. The bucket is required, another one is not required, so we will be using just only bucket over here in our Python program. So now let's paste this code in our Cloud9 IDE, remove this expected bucket owner, and use the bucket argument where we will provide the information about our bucket name from our bucket underscore name variable. Now again we see an error that the client variable doesn't exist. Let's use S3 client instead of the client variable name and get rid of this error. Now this method will return us a response which gonna be a Python dictionary. Let's take a look at the boto3 documentation, how this response looks like. In our specific case, that's gonna be a dictionary which will contain just only one key, location constraint. So now we can use this information to get access to the actual bucket name, bucket location. Let's create a separate variable bucket location and extract this information from the response, from the key location constraint. And now we can slightly adjust our print statement to print the bucket location in addition to the bucket name. Let's save the file and execute our script once more again. Okay, now as you can see, we are printing not only the bucket name, but the bucket location as well. And that's exactly how you are using boto3 client and resources which interacts with the same service. Now, what if you need to filter the output of S3 buckets by the prefix? As you saw, there is no such method available for us through the API. So that means that we have to implement it by ourselves. Let's try to do it. So in our list buckets, let's create an attribute, a parameter, an argument for the method, and call prefix. And let's set it up by default to none. Why we are doing this is just because we would like to give our developers in the future an ability to call this list buckets method without providing any arguments over here. Now, in our for loop, as soon as we got the bucket name, let's check if this prefix variable been set up, and if it been set up, then we can try to use another if statement which will check the bucket name and starts with an actual prefix, and in that specific case we will use these two lines, and else, if that's not the case, we still have to put this line over here. Yep. And if that's not the case, we will duplicate our code over here. So what is the logic over here? So basically, if we set up the prefix, then we're gonna be printing only the buckets which starts from the prefix. If that's not the case, then we will be printing the same information for all the buckets which are available in our list of buckets. So let's try to execute this code once more again, just to check that the method is still providing us the same information as before without any provided prefix over here. And now if we set up the prefix, for example, for SageMaker, a set of S3 buckets, we should get these 3 S3 buckets from the output of our script. Voila. And as you can see, now we have an ability to filter S3 buckets by the prefix using the same list method. So that's it for list method or list buckets functionality. And now it's a good time to start creating and deleting S3 buckets. Stay tuned. Okay, from this moment of time we will move a little bit faster, and let's start defining the create bucket method first. Before doing this, let's minimize the list buckets method definition so that we can have a little bit of space on our screen. Now let's define this. Let's define our create bucket method. So. Basically, jumping ahead, I know for sure that we will need a couple of parameters definitely required for this method. First parameter or attribute for this method would be bucket name, and the second will be AWS region. And by default, I will use US West 2. This gonna be default value for AWS region variable when we are calling the create bucket method. So now within this create bucket method, we need to use a resource and create bucket call API call from the resource. So again, we are going to the S3 bucket to the S3 service documentation, opening service resources. Copy pasting the resource definition, changing the S3 resource variable name. Then we need to click on create bucket method and take a look at which or what arguments does this method have. So let's copy paste the entire example. Of course, we will not explain all the available options for creating a S3 bucket. Instead, we will just use a couple of arguments which we need for sure to simplify this example. First of all, let's get rid of the ACLs. Our bucket will be private by default. Then we definitely need to specify a bucket and location constraint, and all the other parameters might be safely removed. And if you need to specify any additional parameters for S3 bucket creation, just check out the actual documentation and see what parameter or argument is responsible for what in this API call. So as you can see, we stayed with the bucket name, which is a required parameter, and for the bucket in S3 resource create bucket call, we will use a value from provided to our method, which is gonna be bucket name. Now we need to replace this S3 to S3 resource. Just because we are using this method from the resource object. Now the error should disappear. And of course, create bucket allocation. And this is this bucket create bucket location, create bucket configuration expects a dictionary which contains the key, location constraint, and here we should provide the actual AWS region. So let's copy paste this variable over here, and that should be it. So as you can see, the resource, the create bucket method from the resource is returning an S3 bucket object. Why we might need to use this object over here? So if we will go back to the documentation of the S3 resource and click on the bucket, and then click to the actual return type of S3 bucket, and take a look at the bottom to the available waiters section, we will see that we have a couple of waiters over here. First waiter is wait until exists, and the second one wait until not exists. So basically we need to use those waiters right after we created an S3 bucket or destroyed an S3 bucket, just to make sure that we completely created or destroyed an S3 bucket. So let's go to the wait until exist waiter definition, and as you can see, the implementation is pretty much simple. So basically we are calling head bucket API call every 5 seconds until a successful state is reached. So let's copy this waiter definition over here and slightly modify it by removing expected bucket owner argument, which we don't need in our example. So basically that's it. That's how we are creating the bucket. So we are defining the resource, then we are using create bucket from S3 resource, and then we are using waiter to wait till we get a successful state of S3 bucket. So now we can use this method to create our own bucket. Let's call this method create bucket. Then let's specify the bucket name as hands-on cloud demo bucket, and we will not provide any information about the region here, just because we already have it in the method definition. But if you are willing to, we can copy paste it over here and provide this additional information, and for like AWS region, and for example change it to US West 1. So if that's the case, then the bucket will be created in this specific AWS region. So I don't need to do this, and I will simply use this simple definition of create bucket function. So now let's try to execute our script, and I'm expecting that the list buckets method will show us a newly created S3 bucket. Okay, and as you can see, we just created our S3 bucket using boto3 resource. So in the next section, we will destroy this bucket using the S3 resource as well. Stay tuned. Okay, now let's define this delete bucket method to delete our S3 bucket. Okay, what we need to do here, we need to use pretty much the same information over here, and let's copy paste our create bucket method and rename it to delete bucket. Then we probably don't need an AWS region to make this API call, and now we need to get access to the actual S3 bucket, and that's how we are doing this. First of all, we are going to the resources documentation of the AWS S3 service. Now here we need to go to the bucket class. This bucket class has its own constructor which can return us an information about a specific bucket name, and that's how we will basically reference the bucket which we need to delete over here. So we are copying this definition and then instead of using this create bucket call, we will use just simply a bucket class constructor to provide the bucket name over here. Okay, now at this moment of time we will get a bucket, and now we can use this class object to call a bucket delete operation or action. Let's take a look at the actual example. Yes, all we need to do here is to provide this specific information. So let's copy paste it. We don't need an expected bucket owner, and here we go. So the bucket delete will try to delete our S3 bucket, and then again we have to execute a waiter to wait till the end of this delete operation. So again, let's go back to our bucket class. Go to the S3 bucket class reference and open this wait until not exists method. As you can see, again it just expected bucket owner, which we are not using anywhere in our code, and that means that we can simply paste this definition over here. So let's remove the expected bucket owner, and here we go. So the delete bucket method, which we just defined, will create the resource. Then it will use the resource to reference the bucket by its name, which we need to delete. We will get a bucket class object. Then we will use this object's delete method to delete the S3 bucket, and then we will wait until this bucket does not exist. So here's an important thing over here. This method definition will delete just only empty S3 bucket. If the bucket contains any files or versioned objects, this method will fail. As soon as we did not implement those, I would say, methods to work with the resources and objects, we will add required cleanup operations later in this video for this method. As for now, let's just check that this method can delete the bucket. So let's comment out our create bucket and copy it over here, rename it to delete bucket. Then as a bucket name, we will provide our previously used hands-on.cloud demo bucket. And as soon as this method is executed, we should not get it from the list of S3 buckets, from the list buckets method. Let's check it out. Okay, and as you can see, now the bucket has been successfully deleted, and we don't see it from the list of all available buckets in our AWS account. That's it for this part, and let's jump to the enabling version support. Stay tuned. Okay, let's enable bucket versioning support for our S3 bucket. To do this, let's create a separate method to enable bucket versioning support, and let's provide the bucket name as an argument for this brand new method. So to make the things a little bit cleaner, let's minimize those already created methods, and now let's go to the AWS S3 boto resource documentation to find what exact class do we need to use from the boto3 resource. As you can see from the documentation, we have available sub-resources, and one of them is bucket versioning. And that's probably the exact thing which we are looking for. So here's how we are using it. Basically, we are creating an instance of this class by the bucket name. And that's exactly what we are looking for. Let's take a look at the bucket versioning class attributes and methods. And within this class, we can see that we have a bucket name, which is available identifier, and then we have some available attributes, and of course, a couple of actions. And here we will use the enable method to enable S3 bucket versioning support. So all we need to do here is to copy the bucket versioning class definition and boto resource and paste them to our method. So here, instead of S3, let's use S3 resource just to follow our naming conventions. Now, instead of a string of bucket name, let's provide the variable bucket name, and now we have a bucket version object. So here we can call enable method to enable S3 versioning support. So at this moment of time, the bucket will have versioning support enabled. So all we need to do here is to basically, let's print it to simplify all the things. Let's use F string interpolation syntax, bucket support bucket versioning support, and here we will paste the bucket versioning status. And the status is the actual attribute which will show us the bucket versioning support. So okay, now all we need to do here is to create S3 bucket once more again, just because we deleted in our previous example. Then we will list the bucket. And before listing the bucket, we will enable bucket versioning support, just to see that we enable it. And here we go. Let's copy paste the actual bucket argument, and basically that's it. At this moment of time, we will create a bucket. We will enable bucket versioning support for this bucket, list the buckets, and then delete everything. So that should work. Let's execute our script once more again. And as you can see, the first message which we got out of our script is that bucket versioning support has been enabled. That's basically it, how we are enabling S3 versioning support for an S3 bucket. And now it's a good time to jump to the S3 object management part of this video. Stay tuned. Okay, let's recreate our S3 bucket first, and then we will start using this S3 bucket to upload, download, and modify the objects within this S3 bucket. So to do that, we need to comment out a couple of methods here, which will enable bucket versioning support, which we don't need right now, and of course, we need to comment out the delete bucket operation. So let's save the file and execute our script once more again. So at the end of the execution, you will see that we just created our S3 bucket. And let's copy the S3 bucket name and paste it to our objects.py file for the global variable bucket name. So that will simplify us a way to access to the S3 bucket. Now, the next thing we need to do is to go to the S3. Let's go to the client, and within the client, let's find the upload file. So the upload file method allows you to take the actual file from the file system, specify the bucket and the key name under which you need to save this file basically in your S3 bucket. Another method which you probably see on your screen right now is the upload file object method. The difference between those two is that the first one deals with the actual file, and you need to provide here the file location. And for the second one, you are not dealing with the file location, but instead you're working with the data stream. So basically, this method accepts the data stream object and bucket and the actual key, and then it reads the data stream to save all the content from this data stream, all the data from this data stream to the actual key in your S3 bucket. This method is quite useful every single time when you are generating the objects in memory, for example, and willing to store them in S3 bucket. Now, let's copy the example of upload file from the boto3 documentation and paste it over here. So as usual, we are importing boto3 library. Next, we will use S3 resource, and we need to rename it over here as well at line 8. So now, so the first thing we are doing here is creating the resource, which is quite familiar for you. But now we need to provide a region name, just because we will be accessing the bucket within the specific region, right? So to do that, let's define another global variable, which is gonna be AWS region, and we will take the region of our file from here, copy it, and paste it over here. So now, as the region name, we will provide an AWS region over here. So next, the next thing, as you can see at line 9, we are using the resource, then we are using resource metadata to get access to the actual client. So that's exactly what we've mentioned earlier in this video. Every single resource is backed by the actual client operations. So every single resource in boto3 is using the boto3 client under the hood, and then we are getting access to the upload file method. Okay, so within this upload file method, we need to remove the bucket name and the string, and instead of using the string, let's specify the bucket name itself. Now, the next thing which we need to do is to specify or start creating our own upload file method, which we will use in today's video. So let's call this method like upload file, and for this file, for this upload file method, we will need the actual file name. We will need bucket. And we will need an object name specified. So now, within this method, we will use those two lines. And now, let's replace this hello.txt from the example to the actual object name variable, and now the file name, the actual path to the file name, let's replace the string with the actual file name variable. So that's what we need to do over here. And in addition to that, what I personally like to do is to check if object name is none, and then I'm specifying object name as file name. That is quite helpful if we would like to copy paste or upload multiple different files to the S3 bucket, and that particular condition will just take the whatever value is provided for the file name and set up the object name using this specific file name. So basically, if we will upload multiple different files and folders, it will help us to create a nice folder structure which will represent the actual folder structure from the file system. So that's quite useful. Now, what we need to do here, we need to specify the actual main method for this class. Sorry, for this file, and we are doing it using this boilerplate construct main, and then let's call the upload file method. So now we need to specify the parameters over here. To do that, we need to import a couple of additional modules which are embedded to the Python 3. So we will need to import operation system module, and we will need to import pathlib. Of course, let's follow the Python file structure and paste the global variables right after the modules declaration. Now, where we will use this thing. First of all, what I propose us to do is to specify the actual location of this script first. Let's call it base dir, and here we will do the following thing. We will use a pathlib module, then we will use path, and within the path, and for the path, in the constructor of the path, we will provide the actual file. And here we will use parent, and for the parent, we will use resolve method. So basically, what this construct allows us to do, we will use a pathlib module, then we will use a path class where we will provide the file name of our objects.py script, and then we will get a full path location where this objects.py is stored, including the object name. Then we will use a parent which will head us to the actual boto3 S3 folder, and we will use resolve to basically get the location of this folder. Now, as soon as we have the base dir, let's create a folder where we will store the files which we need to upload to the S3. So let's call it files, and within this folder, let's create several files, like demo1 txt and demo2 txt, for example. So now, what we will do here, we will create a path for this files folder, files dir, and we will store this path in the files dir variable. So now, as soon as we know where is the location of the boto3 S3 folder, we will use the operation system library, path, and join. And basically, this method allows us to construct the location to the specific file or any other location. So here we need to provide base dir, and then we'll provide the files. So now that will allow us to get an easy access to the files directory. So now, within this upload file, if you would like to upload one single file, for example, we need to do the following thing. We will use, let's store this in the file. So let's create a variable file name, which will be equal to os path join, and then file directory and the actual demo1 txt file. So that will have the complete path to the demo1.txt. And now we need to use file name equals file name here. Then we need to provide the bucket name, which gonna be our global variable over here. And then we need to provide the object name. So if we will not provide an object name, we will store the actual file with a complete path on the file system in the S3. So let's provide the file name first, demo.txt. Let's save this file, and of course bucket we need to specify all these variables. Object name equals demo.txt. Okay, now the error should disappear and we can safely run our file. And here let's do it objects.py. So the command which we will use gonna be Python boto3 S3 folder, then objects.py, then we are hitting enter, and without any output we should upload the file to the actual S3 bucket. Let's check it out using AWS console right now. Let's refresh our buckets list. Let's go to our hands-on cloud demo bucket. And as you can see, we just uploaded the file, our demo1.txt file, to the folder. So I will pause here, and in the next section, I will show you how to upload multiple files to the S3 bucket. Okay, so to upload multiple files, we need first of all get a list of these files, and then use this upload file method multiple times. So let's get the list of files first. To do that, we need to import additional library or method from the glob module. So import glob, and from glob, import glob. So that will allow us to import glob method from the glob library. That method will allow us to get a list of files, so from the specified path. So let's create the files variable and use the glob method, where we will provide the string, and we will use string interpolation syntax to specify the actual files location or files directory. And here we will provide all the files by the mask, for example txt. So in that specific case, the glob function will select all the txt files from that specific folder and store their paths in this files list. So now we can use for loop to iterate through the list of files. And here let's do one interesting thing. So let's get the actual file name from the file path over here. So to do that, let's create another variable file name, and here we will use os path base base name, and we will provide the file over here. So in that using that specific method, we will store the actual file name, including the extension, in this variable. Now what we can do, we can copy the upload file method over here, and instead of the file name we will use the f, just because f will store the actual location to the file from the files directory. Then the bucket name will stay unchanged, and object name. So within the object name, let's change the string which we are providing here to the f string interpolation syntax. Remove the file over here, specify files, and then provide the f name variable where we are storing the actual file name. So what we are doing over here, so basically we will upload every single file from this files folder to the object name, which will contain kinda a folder prefix, which is gonna be files, and of course we will use the file name from every specific file over here to upload every single file to a separate object name. So now what we can do over here, we can execute the script once more again, and what I'm expecting to get out of it is to see a files folder in our S3 bucket which stores demo.txt, demo1.txt and demo2.txt files. Let's check it out. Okay, let's go to our demo bucket, refresh it, and as you can see, in addition to our demo1.txt file, we have kind of a folder, and within this folder we have demo1.txt and demo2.txt files. That's exactly how you're uploading files to the S3, I mean multiple files, and now it's a good time to start listing the objects from the S3 bucket. Stay tuned. Okay, let's implement S3 bucket listing, and by the way, we will implement filtering as well. So to implement a listing of S3 bucket, let's create a separate method to do that. Let's call this method list bucket, and to list the bucket, we will provide a couple of parameters. First, bucket name, and of course we will add prefix which we will set up to none, like we did for S3 buckets. Now to implement listing, first of all we will use resource and objects collection which is available to us from S3 bucket. First of all, let's get access to the bucket. We need to create a variable for our bucket. Then we need to use S3 resource bucket class, and bucket class, as you remember, have the parameter bucket name, which is provided to its constructor. Now we can use bucket like that objects to get access to all the objects within the bucket. And let's go to the bucket resource, sorry, to the bucket class, and then let's take a look at the objects. So here we have a couple of methods like all, delete, which we are not interested in right now. And then we will scroll down through all these messages and find the filter. And that's the exact method which I would like to use over here to have an ability not only to list the objects within the bucket, but also filtering them by the prefix. So what we're gonna do here, we will copy this method declaration, go back to our Cloud9 ID, objects, filter, and then we will choose just only those arguments which we would like to use. So first of all, we don't need delimiter, we don't need encoding type, marker, max keys, and here we go. Prefix is gonna be the first argument which we are looking for, and of course we probably don't need requester pair and expected bucket owner. So we will use prefix in the filter method to have an ability to filter by the objects. So let's put the output of the filter to the objects list. And now, before calling this method, I would like to add an additional print statement. If prefix is specified, if prefix not specified, I will set up prefix as an empty string. And here, for the prefix, I will provide the prefix. So what we're going to do, what our program is doing here. So basically, we are checking if the prefix is known. If the prefix is known, and then we will set up an empty string. And that empty string will be provided over here. And filter will return all the objects within the S3 bucket. But if the prefix been specified, this condition going to be skipped, and we will use this prefix here to filter all the objects from the filter method, from this S3 bucket. So now, what we need to do over here, we need to use a for loop to iterate over these objects, and let's take a look what kind of object we will return. The method filter is returning not the object itself, but S3 object summary, and that's an exact thing what we are looking for. Let's go back to the S3 documentation and take a look at the object summary class. Within this class, we have a bucket name and a key, available identifiers. So the key will store the actual key name or the location of the file within the S3 bucket. And we will use this information to print the filtered objects. So let's call it object. For object in objects, and then here let's print use f-string interpolation. For example, let's provide a couple of dashes and then space, and then let's use object dot key. And now as soon as we will call list bucket with either oh, I see a type over here. So basically, as soon as we are using a bucket over here, we need to use it in the bucket constructor as well to make this method reusable in our application. Okay, cool. So now this method should work as expected. Let's add an additional couple of lines in our main method and try to use list bucket. So for the bucket name, we will provide bucket name, and let's try to use it first without any provided prefix, right? So what I'm expecting to happen here, as soon as I will call this script, first of all, it will upload all the files once more again. Basically, it will replace all these objects in the S3 bucket, and then we will list them. So let's call our Python script, and here we go. As you can see, we printed all the objects available in our S3 bucket, including the folders as well. So now let's try to use prefix here, and for the prefix, let's specify the files first. First of all, I'm not providing any slashes over here, just to show you how this prefix is actually working. So let's call it once more again, and as you can see, we have just only 2 files, right? So now what I would like to do is to tell you that the actual file key is treated as a single string. So basically, this files is not the actual folder, it's just a part of the file of the key name, right? And if I will provide something like demo1 here, we will get just only this object, just because this selected part will be filtered by the filter method. So let me to save the file, execute it once more again, and voila, we are getting just only 1 file. So that's exactly how you are filtering or listing S3 bucket content and getting either all the objects or filtering the list of the object by specifying the prefix. Now let's take a look at how to download the files from this three buckets, and see you in the next section of the video. Stay tuned. Okay, what I propose us to do to simplify the downloads object method creation. So first of all, let's implement an additional method over here, which we will call the get S3 objects versions. So we will use the same arguments for this method, and within this method we will put almost entire meat of the list bucket method, and let's rename objects to objects versions, and return this list to us, and return this thing to us back. Objects versions. Okay, now we can use this method over here in list objects. Let's create this variable objects versions, and then it will be it will get the values from get objects, and we need to pass the prefix variable over here. Okay, now as you can see, we slightly modified the list bucket method. So let's check out that we did not break anything here. So I'm expecting to return our object over here. Okay, now we can reuse this get objects versions method not only to list buckets, but also to implement the download files from this three bucket method. So let's create this method. So basically we are defining a new method. Let's call it downloads S3 objects. We will use the same arguments over here, and now within this method we will get a list of objects returned by the prefix, like we are doing in the list objects, but instead of printing them, we will be downloading them to the specific folder. So as for now, I will put pass in this for loop. So let me to rename object to object version to make the code a little bit more cleaner. Now we need to create the folder within this folder structure where exactly we will download the files. So let's create a new folder here and call it downloads. Now we need an additional global variable here. Let's call it downloads directory, and here instead of files we will use downloads. Okay, so now this downloads directory will contain the path to this downloads folder on our local file system. So next, every single object version have a reference to the object. So let's check it out from the documentation. So I'm clicking on the object version, and here we see that we have a sub-resource of object, and that's exactly what we are looking for here. So now let's check out what the object class provides to us. and I'm expecting here to use the download file method. So this download file method accepts the local folder and the actual file name where we need to save the object from S3. So what we're gonna do here in our method, so let's create another object variable, and we will get an object from the object version. Now this object will contain the information about the actual object stored in S3 bucket, and now to be able to save the objects to the to the downloads folder, including the subfolders where the files are stored, we need to add we need to do a couple of manipulations. So first of all, let's get access to the object key. So object key will be object.key, and that object key will store the information like demo.txt or files demo1.txt or files demo2.txt, right? So now we need to parse this key string to get information about the subfolders and the actual file names. So let's create a couple of additional variables, S3 subpath, and that will be key object. We need to split this object by the slashes and take everything except the file name. So that's going to be the last element from the list. Now we need an S3 file name, and that will be an object key split by the slashes, and instead here we will just take the last element without all these files and prefixes. Okay, now let's define the subfolder within this downloads folder. Let's call it local subfolder, and we will construct it as ospath join, and here we will use a downloads directory, and then in addition to this downloads directory we will provide an S3 subpath. So but S3 subpath is a list, but ospath join accepts a string. So now we need to basically join this folder list back by using join method of the class string. So basically what's gonna happen here is that all the folders like files or any other nested folders from the list will be joined using this slash, right? So now as soon as we got the local subfolder, we can check if it exists. So or if it not exists, that will be better. If not, ospath exists, and then local subfolder. So if this local subfolder path not exists, let's create this folder structure for us. To do that, we need to call osmkdir and provide it with a local subfolder path. Now, as soon as we formed the folders, if we are facing some in the downloads folder, we can safely use this object and its download file method to store the file from the S3 folder, right? So here we need to call auth path join, and then let's join the local subfolder and the actual S3 file name. So as for now, I think we should be good to go. And whenever we will call this S3 download S3 object method, it should download one or many files, including subfolder creation. So let's try to execute this very quick. So I'm copying this method declaration over here. I'm commenting out this list bucket method, just because we don't need to print the buckets. So I will copy this bucket name over here, and let's specify the prefix first, just to check that the prefix is working. And we don't need this last symbol over here. Okay, cool. So what I'm expecting to happen right now is that downloads S3 object method will query a list of files which starts from this specific prefix. We will get just only one file which is located in the S3 subfolder. Then we will parse this key name, get the local subfolder within the S3 folder path. If it doesn't exist, we will create one, and then we will download file to that specific folder location. Let's try to execute this script very quick and see if we didn't miss anything. Okay, cool. So we just executed the script, and it looks like the IDE did not refresh the file tree. Let's do it ourselves, and as you can see, we just downloaded demo1.txt file to the files directory within the nodes folder. So now let's try to remove this prefix from here, and that will provide none to the prefix. Then this method will return all the objects, and we should get this exact specific structure within the downloads folder. So by the way, we can remove these comments. We don't need them anymore. So let's try to execute the script once more again and refresh the file tree. And here we go. As you can see, right now we are completely mirroring the S3 folder structure within the downloads folder. So we have this files folder where we have two files, and the demo.txt file which is stored on top at the root of the S3 bucket itself. Let's refresh it here very quick and check it out once more again, just in case. Here we go. And that is how we are downloading files, one or many, to our local file system from S3. And in the next part of the video, I will show you how to delete S3 objects from the S3 bucket. Stay tuned. Okay, it's time to show you how to delete objects within S3 bucket and object versions in S3 bucket. So basically, it can be achieved in a similar way. So let's implement the delete objects function. So basically, we will use the same syntax where we will specify the bucket and the prefix for which objects which will show us which objects we would like to delete. So let's call delete S3 objects file here, and specify path over here. So basically, to delete objects within S3 bucket, let's go to the bucket class of boto3 resource. So here's how we gonna instantiate this class, and then we need to pay attention to a couple of collections over here: objects versions and objects, and we will be using those two collections to filter and delete objects and objects version. So let's start from the object first, and we will objects and objects versions collections have the same interface, so we will just replace the collection with another method. So here, as you can see, we have a delete method which allows us to completely clean the collection, and we will use it if we are not specifying any prefix. So then we need to scroll down a little bit, and here what we need to pay attention to is this filter method. So this filter method allows us to use prefix to filter object by the prefix, and then it will give us an object summary list, which we will, where we will use delete method as well. So let's go back to our method, and here's how we are doing this. So let's create a new bucket. So first of all, we need to create a resource within this method. Then let's instantiate the bucket using S3 resource and bucket class. Here we will use the bucket from from the arguments of this method. And now let's introduce a simple condition. If prefix, so basically that means if the prefix being specified, then bucket objects filter then prefix equals prefix and delete. And now else, so if prefix not specified, then probably we are looking for deleting all objects from the bucket. So here, instead of using this construct, we will remove the filter over here and rely just only on delete method. So basically that's it. That's how we are deleting all the objects from the S3 bucket, and we are doing the same thing for deleting object versions. So if your S3 bucket has this version enabled option, right, you are not deleting the objects, you are just creating a marker that the object being deleted. So to clean up the history of those marker modifications, we have to delete the object versions, right? So delete S3 objects versions, and here all we need to do, instead of object, we need to use this object version collection. So I'm copy and pasting it over here, and instead of objects, I'm using object versions collection, and that's basically it. So right now our bucket does not have any object in, any versions, it doesn't have versions enabled flag setup. So basically let's try to delete object versions first for our bucket, just to make sure that this method is not causing us any issues. Now let's run everything, and as you can see, as soon as these collections doesn't have any objects, this delete method will just execute on an empty collection, and it will not touch anything or cause any exceptions. So now let's try to delete our objects. Let's comment out this download objects method first, then we will delete objects, delete object versions, then delete objects. Basically, the right sequence should be like this. So first we are deleting all the objects. If we have a bucket, S3 bucket versions enabled, then we should delete object versions. So now let's fix this small issue over here, and then we will list bucket just to make sure that we don't have any objects over there. So let's execute our script once more again, and we should get an empty output. As you can see, right now the script doesn't provide us any output. That means that all objects are being deleted. So now we can simply use these two methods just to create an additional method like empty S3 bucket. And here within this method we will use pretty much the same number of arguments, and here we will just add this prefix equals prefix, and here we are doing the same thing. So now instead of like calling these two methods sequentially, we can like use this just empty S3 bucket method, and that's how you are emptying S3 bucket. So now we can safely do something like empty S3 bucket, put it over here, and then delete this two methods which are not used right now. So, okay, we just executed everything once more again, everything is working, and now it's a good time to jump to the copying and renaming or moving objects within S3 bucket topic. So stay tuned. Okay, now let's implement a method which will allow us to copy object within S3 bucket from one location to another. So let's define a new method which we'll name copy object. Then this method will accept bucket as a parameter, then source object name and destination object name as well. So now let's use the resource which we already defined in various different other methods, and now to copy the object from one location to another within the same S3 bucket, we need to use the object class which points us to already existing object by the bucket name object key, and within this object we need to use copy from method. So if we will take a look at this method allows you to specify a whole bunch of like different parameters, including encryption, metadata, access controls, and many others. We will not use various different options over here, but instead we will simplify this method just to point us to the copy source of the object. So what do we need to do over here? So let's create a new object. We will call it object. No, we will use S3 resource. Here we will create an object. Here we will specify the bucket and destination object. And for this non-existent destination object, we will use copy from method, where we will specify this copy source string. And the string basically consists of a couple of parameters. First should be our bucket, and the second should be source object name. That's basically it. Now what we can do here, we can comment out our empty S3 bucket method. So these two lines will create a set of files or upload a set of files to the to our S3 bucket. Let's execute the script just to populate our S3 bucket with a couple of files. Now we have 3 files over there. One is in the root source folder, and a couple of others which are sitting in the files folder. Okay, so now let's use our copy object method to copy demo1 txt to demo2 txt. So here's how we are doing it. Here we are providing the bucket name, and then within the for the source object we will use demo1 txt, and for the destination we will use demo2 txt. And as soon as we run our script once more again, our list option, so what's the error message over here? Oh yeah, of course we have to specify the arguments. So let's specify it over here like this, and destination object like this. Okay, so the error should disappear in a second. Now, as soon as we will execute our script, we should have demo1 and demo2 txt files sitting in the root source, in the root of S3 bucket, and then demo1 and demo2 txt files which are sitting in the files folder. Let's execute our script once more again and take a look what's going to happen. Okay, as you can see, we just copied a file from one location to another. Now, what we can do in addition to that, we can define the method which will be similar to our previous one, but instead of copy, we will implement move operation. So now, as you can see, this method will these 3 lines will copy the object from one location to another, and now we can we need to delete the source, the object source basically. So we are copying this line once more again and calling here delete method. So now what this method does, it will copy the object to a new location first, and then delete the source object. Of course, you can use move method not only to move the object but to rename them as well, right? So let's take a look. For example, let's copy this file once more again, copy this thing, rename the method to move, and then let's move, for example, demo2 txt to demo3 txt file. And now we should get a list of files which will contain demo1, demo3, and a set of files sitting in the files folder. Let's execute our script and take a look what's going to happen. Okay, why it's not working? Let me to double check it very quick. Okay, this is the object. This is the destination object, and of course, yeah, this is my mistake. So here, instead of destination, I need to specify the source object. This was like my small mistake. Let's execute once more again, and here we go. Demo1 txt, demo3 txt, and a couple of demo1 and demo2 txt files sitting in this files folder. That's exactly what we wanted to achieve. And the last thing which we would like to show you today is gonna be how to generate pre-signed URLs for your objects in a S3 bucket. Stay tuned. Okay, let's implement our last method for today's video, where we will generate pre-signed URL for the object, and will allow our clients to download this object without having any credentials to our AWS account. So to do that, we need to define the method itself. Let's call the method generate pre-signed URL, and this method will accept bucket for which we will generate pre-signed URL and the actual key of the object. Let's call it object key. Now, the boto3 resource does not allow us to generate pre-signed URLs. So instead of using the resource, we have to use client. Let's use the client for accessing S3, and now we can generate pre-signed URL. So let's create the URL where we will store this URL, and then we will use the client. Now let's go to the boto3 documentation, open the client section, and find this generate pre-signed URL for our method. So let's copy paste the method definition, paste it over here, and then let's start implementing or providing all these required parameters. So the client method will be get object. The parameters should contain the actual dictionary, which contain the bucket and the key. We don't need to provide an HTTP method here, and here for the parameter, let's define the dictionary for the bucket. That's gonna be bucket, and the actual key will be an object key. Okay, and here we go. So now this generate pre-signed URL method will generate a URL for us, and we will print it to the screen. Let's print the message download URL, and then let's use formatted string, and here we will provide a URL. Okay, so now let's comment out our methods here and generate the pre-signed URL for demo1.txt or demo3.txt file, which we have in our S3 bucket. So let's copy the method itself. Then let's provide bucket name over here, and for the object, let's download the object which is located in files and demo1.txt. Okay, fine. So now what should we do? We need to execute Python boto3 S3 object py, and we should get our download URL, which we can copy. And of course, now we can use curl command or better wget to download the actual file to our folder. Let's try to do it. Cannot write the file. Okay, let's use curl -o demo1.txt, and that should help us to solve our problem. Let's try it. Yep, here we go. We just downloaded our demo1.txt file from the files demo1.txt object location within our S3 bucket. So thank you for your attention. If you like this video and find it useful, please subscribe to the channel and hit thumbs up button. We will be releasing new videos quite soon. Thank you for your attention. See you in the next videos.